Today we're going to talk about trapezoids. So the first thing you need to know about a trapezoid is the definition of a trapezoid is that it's a quadrilateral with one pair of parallel sides. So just one pair of sides is parallel and the other two sides are not. The parallel sides are called the bases. So we have base 1 and base 2, and the other two sides are called the legs. Since the bases are parallel, we do know that this angle and this angle are going to be supplementary. And the same is true for these two angles over here. They're going to be supplementary, but there's no guarantee that any of them are congruent. We just know that because of the parallel lines and the same side interior angles, these two are supplementary and these two are supplementary. The mid segment of a trapezoid is the segment that connects the midpoints of the legs. Connects the midpoints of the legs. So what that looks like here is these will be labeled that this is a midpoint, and this will be labeled that that's a midpoint, and this is your mid segment. Now the mid-segment of a trapezoid does two special things. First of all, it is parallel to the bases. So we could add in a little parallel there. And also, it is half the sum of the bases. So if I were to add base 1 and base 2 and take half of that, I would get the length of the mid-segment. So those are the important things you need to know about the mid segment of a trapezoid. There is a special type of trapezoid called an isosceles trapezoid that has some special characteristics. And of course it's got the two bases are parallel. That's the definition of a trapezoid. And the other thing that's important about an isosceles trapezoid is that the legs are congruent. A trapezoid has congruent legs. An isosceles trapezoid also has congruent base angles. So when we talk about the base angles, we're saying these two angles are congruent to each other, and these two angles are congruent to each other. Those are called the base angles. The two angles that are on the same base are congruent to each other. And as I said over here, these two angles, the consecutive interior, same side interior, they are supplementary, and these two are supplementary. Not the opposite angles, just these two. And the other thing we need to know about an isosceles trapezoid is that the diagonals of the isosceles trapezoid are congruent to each other. So we'll put diagonals are congruent. Only for an isosceles trapezoid, not for just a regular trapezoid. So isosceles trapezoid has special rules there. The next shape we have is called a kite. A kite, some people look at it and they say it looks like a diamond or some other things, but it looks like a kite. So a kite is a quadrilateral with two pairs of consecutive congruent sides. So this is by no means a parallelogram or a trapezoid. A kite is its own thing. Two pairs of consecutive congruent sides. I guess I could write out the whole word there. Okay, so in our kite, and it's kind of obvious by looking at it, these two are congruent, and these two are congruent. I guess I should put extra markings since I've already got some there. So on the two sides next to each other are congruent, and it's pretty obvious that these two are not the ones that are congruent. In a kite, we have the diagonals are perpendicular to each other. So you can see here in the center, we've got that right angle. And the diagonals, I should say one diagonal bisects the angles, and it also bisects the other diagonal. So this diagonal right here, the longer of the diagonals, this one, cuts these two angles in half, bisects those two angles, and you can tell by the hash marks here, it bisects the other diagonal. So if you look carefully, you'll notice that these two triangles at the top are congruent to each other, and these two triangles on the bottom are congruent to each other. Not this way, but this way. So one of the diagonals bisects these two angles, and it also bisects the other diagonal. So there's a lot going on there with our kite, and we'll have to see how that works in some pictures. All right, so let's take this new information and do a couple of practice problems. Here we go. This one says find the value or values of x in the trapezoid. So notice they told us it was a trapezoid, so we know that these are parallel because that's what they told us. Notice what kind of segment this is right here. We have this point is the midpoint of this side. This is the midpoint of this side. So we have a mid segment. And we learned that the mid segment equals half of base 1 plus base 2. So I'm going to take base 1 plus base 2. And because I don't want to put a half here, I'm going to multiply the mid segment times 2. Because that's the same thing. If the mid segment is half of 20, then the mid segment is going to be twice as much, or the mid segment times 2 is going to equal the two bases added together. Notice we have a quadratic here, so we're going to at some point have to factor and use the zero product property. So x squared plus 36, distributive property there. Let's get everything on one side equal to 0, and we'll see if what we can do from there. So we make one side equal 0, and then we factor. So our problem here is finding factors of 48 that add up to negative 14. So if that stumps you, you could start listing all the factors of 48. Let's see, 1 times 48, 2 times 24, 3 times 16, 4 times 12. Nothing adds up to 14 yet. 6 times 8. We have a winner. So it's x minus 8, x minus 6 equals 0. So my possible answers are x equals 8 and x equals 6. And now we'll go plug them back in and see what happens. If x is 6, this one's 36, which it's supposed to be, and the one in the middle is 36, right? If I plug in 6, 42 minus 6 is 36. Well, they're all the same if x is 6, but that does work because 36 plus 36 is 72, and if we divide that by 2, we do get 36. So 6 is a possible answer. Let's check the 8. Does 8 work? If I plug 8 in here, I get 64. If I plug 8 in here, I get 56 minus 6 is 50. So let's check that out. 36 plus 64 is 100. Half of 100 is 50. They both work. So x could be 8 or x could be 6. So the mid segment of a trapezoid, you either take half of base plus base, or you could say 2 times the mid segment equals the bases added together. Just sometimes one equation is more convenient than the other, and this time I used the times 2. Let's take a look at number 11 over here. This is an isosceles trapezoid, so we know those are parallel because they told us it was a trapezoid. The legs are congruent. So remember, with an isosceles trapezoid, we had the base angles are congruent. So that means this angle and this angle are the same. That means this angle and this angle are the same because they're on the same bases. So if this is 110, this is 110. Now, we also know because of the parallel lines that these two angles have to be supplementary. So this angle must be 70. And now I can solve for x. If I say 2x minus 6 equals 70, then I add 6 to both sides, and x equals 38. So that's some information about trapezoids. Let's look at a couple of kite questions. Find the missing values in the kite. All right, well, we know that in a kite, the diagonals are perpendicular. So I've got some right triangles here. I could find x. I know the 6 and the 12. X is just the hypotenuse of a right triangle. So I'm going to say that x equals the square root of 6 squared plus 12 squared. Now let's see what that is. 6 squared plus 12 squared. 180. So x is the square root of 180. We don't want you to hit the button and give us an estimate. We want you to simplify the square root. So if I divide it by 9, divide it by 4. So I think, let's see, I think the answer is 6 root 5 if I break down 80. Let's see if I can show you that. I got 9 times 20. Of course, 9 was 3 times 3. 20 is 4 times 5, and there's a 2 times 2. So there's our 6 root 5. That's x. Well, now let's find w. We're going to do something similar, except w is the hypotenuse with legs 4 and 6. So w equals the square root of 4 squared plus 6 squared. So let's see. 52. The square root of 52. So if we break down 52, I think it's divisible by 4. It's 4 times 13. And of course, 4 is 2 times 2. So w is 2 square root of 13. And remember, the definition of a kite was that it had consecutive congruent sides. So z is also 2 root 13. And y is also 6 root 5. Notice that one of the diagonals was bisected. The other diagonal is not. So that's what makes it a kite. Let's look at the second picture, which has to do with the angles in our kite. We know that the diagonals of a kite are perpendicular. So there's a 90-degree angle. And remember that this one diagonal bisects the angles. So if this entire angle is 60, it just got cut into 30 times 30. So this is 30, this is 90, this angle is 60 degrees. Remember, that's also a right angle, 30, 90, this one's 60. Well, this entire angle was 110, so if part of it was 60, the other side must be 50. And we go through the same process. Here's our 90, our 50, and a 40. Since this long diagonal bisects the angle, C must also be 40. So notice these two angles were bisected. This angle was not bisected, just the angle along the longer of the two diagonals. And that pretty much sums up what we need to know about kites and trapezoids.